Okay, so the final question in the video is this question, and it's about elasticity. Now, this question, the function given here, it might be a bit more of a trickier function that you might see in a tutorial or even in an exam paper, but there's no harm in doing trickier questions, because then if you can get through this question, a simpler question shouldn't be as bad at all. So we have this demand function here, P equals that expression. And what we're asked to find is the price elasticity of demand when Q equals 1. Okay, so what's the formula for elasticity? It's E equals minus P over Q by dQ dP. Now, so let's tick off the terms. What do we need here? Well, we need Q. Do we have Q? Yeah, we do. So Q equals 1. We'll need P. How are we going to get P, the value of P? We're going to sub in Q equal to 1 into that, and we'll get the value of P through that way. That's fine, so we know that. Now, dQ dP, what are we going to do to get that? The thing about the way this is written is this function is written, it is a function, P is a function of Q. Let's just take it down in bigger writing here. P equals 100 over the square root of 3Q squared plus 2Q plus 1 minus the square root of Q. Now, the only sensible thing, if I differentiate that, the only thing I can call it is dP dQ. There would be no sense, that's what I call it, there would be no sense in calling it dQ dP. It wouldn't make any sense to call it that. The same way, if I go over to the side of the page here and say y equals x squared, then the derivative is called dy dx equals, and that equals 2x. I don't call it dx dy. The only sensible thing to call it is dy dx. So I can only call the derivative that dp dq, and I can't call it dq dp. So, but in the formula, I need dq dp. So the good thing about that is what I'm going to use to find I need the switch, I need it the other way about. What I'm going to use is this rule that dq dp is the same thing as 1 over dp dq. So I can find that. Now we might have a job to find it, but we can find that there. So that means now we can find dq dp, and we're going to have all the terms we need to find elasticity. So what we'll do first, while we have P on the screen, let's sub Q equal to 1 into the expression for P so we can find the value of P. So what we have is, we're going to have some subbing Q equal to 1 into that P there. So I'll have P, and I can write it as P of 1, the same way you should write f of x and f of 1. The value of P when 1 is subbed into it, let's just go straight over to the calculator. So, and what I'm going to do here to just to be on the safe side, in case I sub something in wrong, I'm going to use this answer button again. So I want to sub 1 into an expression. So like 1, your latest answer, by just pressing 1 equals. Now type the expression in, but pretend that answer button is the Q button, even though it sounds odd, but just pretend that button has a big letter Q on it. So we have big fraction 100 divided square root, and just type what you see, 3q squared plus 2q plus 1, get out of that fraction, and minus root q. Okay, so what that does is and I get this odd expression, so let's change it to decimal. It subs q into that big q equal to 1 into that big expression, as in on the calculator it subs 1 was my last answer, and it subs 1 in for that answer there. So I had 39.82, so let's just take that, 39.82, okay. Now, so I'm going to differentiate, next thing I'm going to do is differentiate that expression here. Now I'm going to have another little talk before I even think about attacking that thing there. So let's just go down to a nice new area in the whiteboard, and I have P equals that there. Okay, so a little talk. If I see, I'll say it like this, I can differentiate anything that looks like x up to the p. I've no problem with that there. How do I differentiate that? Because I take the power down and I take 1 off it. But what about things like, what about the square root of x? What can I do with that? Or 1 over, we'll say, x to the power of 3. What can I do there? I need to rewrite it so that it's something x up to a power. So in the square root case, and it's something you'll have to remember, the square root of something, the square root of x, is the same thing as x up to the half. And when I have when the x is on the bottom of the fraction, I'm allowed to take it up, but I must remember to change the sign of the power. Okay? Now I have no problem differentiate them, because in that case I take the half down, take 1 off the half. In that case, take the minus 3 down and take 1 off the minus 3. Now there's one more thing. What about the mix of them cases? What if I see 1 over the square root of x? Well, first thing I'm going to do, let's use this rule first. That's 1 over x to the half. Okay, now use that rule. Take the x up, but change the sign of the power. And now I can differentiate that, no problem. Take the minus a half down and take 1 off it. And one final thing, what about if there is a number? Let's just actually put in a 7 there. You know, if it's not 1, it's a 7. Let's change that to a 7. Then, well, from when I go from there to there, nothing happens. But the same idea, nothing is going to happen at 7. He just remains at the side. He's just a stander by. He's nothing, he doesn't change it. Don't be changing the power, don't be changing that 7. He's just beside, he stands along the x. So what was all that talk about? That talk was about, if you ever see any expression on the bottom like that, and if I ever see square root signs, let warning bells go off. You cannot differentiate them straight away. You need to rewrite them. You need to change how they look. So after what I said at the side of the page, I'm going to change that P. I'm not differentiating it yet. I'm only changing it how it looks. I'm sort of preparing it for differentiation. Warning bells should go off when you see square roots and when you see x's or terms in the bottom. So that's when you need to change how it looks. So in one move, the first thing I would do is change that all up to 3q squared. Let's just change colours again. 3q squared plus 2q plus 1. That term, change that to on the bottom up to the half. But then in a further manoeuvre, I'm going to take all that up to the top, but minus a half. What are you going to be left with? Again, a number in the top doesn't matter, keep them at the side. I'm going to be left with that big mess there, the 3q squared plus 2q plus 1. On the bottom it was up to the half, and on the top it's going to be up to the minus a half. Okay, and this isn't so bad now. This is just going to change the minus q up to the half. Okay, now I'm nearly ready to differentiate. But I need to have another little talk now before I do that again. And because I'm looking at that and I'm saying, I wouldn't, if it was just q to the minus a half. Okay, we'll let's pretend that that was q to the minus a half. Okay, I would have no problem with that. Again, take the power down, take 1 off it. But I don't have that. I have this big mess trapped inside and up to a power. So what happens when I see that there? When I have, again, I'm going to the side of the page here. When I have a function, we'll say y equals a big function inside here, but trapped up to a power. then what I've this saying to attack, and it's really, I use the chain rule here, but I don't want it to go through all the big effort of using u's and finding du, dx and sub. I just want to be, can I do it quickly and easy without making a big deal about it? Then I've this saying, ignore the inside, ignore inside, and deal with it later. With it later. What do I mean by that? I mean, that's my inside there. I've this big expression all trapped up inside a power. So I'm just going to pretend it's not even there, okay? So I would just if I just pretended it's not there and ignore it, I would say, sure, just take down the p. I would just say, sure, just take down the p and take one off it. Ignore it. Just pretend it's not there, and I would get p. Pretend that function isn't there. F of x. Keep it inside. Let's just keep it. Let's even write it like that, f of x up the p. Then ignore it, take the p down and take 1 off that p. Now, I've ignored the inside, but straight away I must open up a bracket now and deal with it right now. I said I'd deal with it later. I've ignored it there, but I must deal with it later, and here's the time now to deal with it. And you put the derivative of that, attack the inside function, differentiate it straight away afterwards. So just a few examples. Suppose I had, e.g., y equals x squared plus 1 all up to the power of 5. Okay, so I have this inside function here. Ignore it. So I'm going to just pretend it's not there and say, sure, just take the 5 down, pretend that's not there, and take 1 off that 5 to get 4. Now you have to open up a bracket and deal with what you ignored. I ignored that, so I'll have to attack it, and I would get 2x. Another example, y equals the square root of 3x squared plus 5. I'll put it like that. Okay, warning, say that to yourself. Warning, warning, can't differentiate square root, must change it to up to the power of a half. So before you even think about differentiating, change it up to the power of a half. So I have all that mess there up to a half. And what do I have? A term trapped in a power. So I ignore the inside and deal with it later. Y dash equals, take the power down and ignore the inside, take the power down, ignore that inside, and take 1 off the power. Now open up a bracket straight away and deal with what you ignored. I ignored that, so I have to differentiate that. Now I would get, take the 2 down, but there's a 6, take the 2 down, but there's a 3 to meet it, it'll get 6x, and then the 5 disappears. So after that side of the page talk, let's go back to our main task. What was it? To differentiate this mess here. So this is our inside function, and is trapped inside a power. So we ignore it and we deal with it later when we're differentiating it. Okay, so we have, what are we going to do? Ignore it, just take down the minus a half, ignore the inside function, skip over it and take 1 off that power. And then straight away open up a bracket and deal with what we ignored then. Now we have dp, I might have left not a lot of space, but anyway, dp dq equals, so I have 100 already there, and the minus a half is coming down to meet him. Okay, minus a half coming down to meet him. Skip over the inside function, just ignore it. 3q squared plus 2q plus 1, and then take 1 off that power, that minus a half. Now if you're stuck on that, just go over the calculator, minus 1 over 2, and take 1 off it. What do I get? Minus 3 over 2. That's fine. Now I ignored the inside and I must deal with it straight away now. So differentiate the inside function. That's not too bad. I'll get 2 comes down. I'll get 6q plus 2. Okay, and I'm finished with that term, and this is much easier after all that big mess. That half comes down, but there's a minus to meet it, so I get minus a half q and take 1 off that half. If you're stuck in that again, 1 over 2 minus 1 minus a half. Okay, now as bad as that looks the good thing about it, I don't need to clean that up anymore, because remember what I was looking for. I'm looking for the overall, what I'm looking for is elasticity. Let's go now. So I need the value of dp dq. What is the value dp dq when I sub in 1? Now I don't need to sub in 1 on pen and paper there. Let's just go with it. Let's just save time and just go by using the calculator. Now we have a lot to type in, but we would have to anyway. So what we're going to get is, I want to sub in 1 into that big expression. So use our answer button. 1 equals, and now that means 1 is our latest answer. So let's type everything in as we see it. 100 minus 1 over 2. Just type what you see, and it'll all work out then, as long as you stay safe and use the brackets and type what you see. 3 answer squared plus 2 answer plus 1, close the bracket, up to the power of minus 3 over 2. Get back out on the main line. Whoops, I went too far, go back over. Another bracket, 6 answer plus 2. All minus another fraction, 1 over 2. Get out of that. Answer up to the minus 1 over 2. Right, so a lot of typing, but it's worth it, because it's mistake proof. So let's take that down. We have minus 27.72. We'll just do with the 2 decimal places. Minus 27.72. Now, as we said, I need dq dp, not dp dq. So how do I get it? The switch is 1 over the original. We'll put it like that there. That's kind of what that says. The switch is 1 over the original. So we have, that means dq dp equals 1 over the other one, dp dq, minus 27.72. Now leave it like that, because we're eventually going to throw this again in the calculator to get the final figure for elasticity. So leave it like that, don't worry about working that out. So do we have everything finally that we need? Yes, we have the p, yes, we have the q, and now we have the dp dq. So we're ready to sub into that formula. So we're going to have E equals minus, what did we get for P earlier on? We had, when we subbed in the Q value for P, we got 39.82. Sorry, just underline, we got 39.82. 39.82 over Q, which was 1, by dq dp, and after the whole rigmarole we went through to get it, we have it 1 over minus 27.72. 1 over minus 27.72. Again, just don't work it out in steps, just you have all the numbers, so throw it right in the calculator. So minus fraction 39.82 over 1 by another bracket minus fraction minus 1 fraction, well, whatever, it doesn't really matter what way you type that in, we'll just type it as we see it then. 1 over minus 27.72. Out of that, close the bracket, equals, get to a decimal place, 1.43. So E equals 1.43. Final answer there. Okay, for the very final part of the question in the video, we have part B. Estimate the percentage change in demand. This part here. Estimate the percentage change in demand if the price decreases by 2%. Okay, I might just take that down with me. So what they're looking for here is for you to know the relationship between elasticity and percentage change in demand and percentage change in price. Now, the thing about it, it's the first two formulas, I think, in the business maths book. There's a relationship for percentage change in demand, and then there's another relationship for percentage change in price. The tricky bit is the sign in front of it. So if at the very least, if you could try and remember this, and I have a little saying now to help you remember the sign. So elasticity equals percentage, and both of them, both formulas are all over percentage change in price. and percentage change in price. I put it like that: percentage change in price and P. Both formulas are over that there on the bottom. Change, sorry for the bad writing, and price. Okay, and the relationship for supply is percentage change in supply, and percentage change in demand for the demand relationship. Okay, percentage change in demand. Now, but there's a plus in front of one of them and a minus in front of another. Now, my saying is, think of a car speeding or speeding. What that's saying, what comes out of that is that the supply formula has a plus in front of it, and the demand formula dn has a negative in front of it, a minus. So speeding that might be a little bit of a help there. So for supply, this one is a plus, and for the demand equation is a minus. So I want the relationship I need. What did they mention to me? What did they say to me? They said change in demand and percentage change in price. That's fine. So I need to use this formula here because that's the relationship between demand and elasticity. So that formula says that E equals percentage change in demand over the minus percentage change in demand over percentage change in price. What do I know? Well, I know elasticity is 1.43, so let's fill that into our formula. 1.43 equals minus, now I'm looking for the percentage change in demand, so let's just call that X, okay? Because I'm looking for that. And percentage change in price. What did they say? If the price decreases by 2%. So that means the percentage change is minus 2. If it increased, it would be plus 2, but it's decreased, so it's a minus 2 there. Now, don't be afraid. Don't be afraid of an equation like that. I know there's a lot of minuses there, so one thing maybe the easiest thing to do here would just say, well, sure, a minus in the top and a minus in the bottom sort of cancel to become plus. So what you're really looking at there is 1.43 equals x over 2. Okay, so and the next thing, what am I going to do there? 2 is being divided on on that side. So when I take it over the other side, it's the opposite operation applies, multiplication. So what I have there's 1.43 multiplied by 2, because it was divided by 2 on the other side. So when I take it to this side, it's multiplied by 2. No sign change there, equals x. So really, if I go to the calculator, 1.43 by 2 equals, get a decimal place, 2.86. So 2.86 equals x, or in other words, x equals 2.86. So let's better describe that now. It's a plus, just because it doesn't say it in the calculator, it's a plus 2.86. So that means percentage change in demand, or how do you want to say it? So we'll just say price increases. Why increases? Because the plus there. If it was minus, we would have to say decrease. So the demand increases by 2.86%. Okay, that's the end of the video. Thank you.